Welcome to the Engineering Update. I'm Casey Panetta, editor of ECN. In this week's episode, National Engineers Week, an exoskeleton without a power source, and an inexpensive way to detect explosives. This week is National Engineers Week. Founded in 1951 by the National Society of Professional Engineers, National Engineers Week, or E-Week, is focused on expanding interest in and knowledge of engineering fields to ensure that the future workforce is diverse and well-educated. Part of the week is devoted to ensuring the conversation about engineering is compelling. One major barrier to students entering the field is that they might not really understand what engineers actually do, and their counselors or family members might not be equipped to explain it properly. The National Academy of Engineering joined with the National Engineers Week Foundation to offer up better explanations for students and better materials for teachers and parents. There's also a component of the week that focuses strongly on getting kids interested. This includes things like Designing a Future City, which is a semester-long project with 33,000 students, and New Faces of Engineering, which highlights the accomplishments of college-level engineers. Today is Introduce a Girl to Engineering Day. This is the 14th year the organization has celebrated this specific day, but has evolved into a national movement. The week is almost over, but there's still time to learn more about how you can make a difference in the life of a future engineer.
Most wearable exoskeletons are heavy-duty contraptions with ravenous power requirements. Lockheed Martin's Human Universal Load Carrier, or HULK, shown here in a rough sketch, was a battery hydraulic-powered load carriage platform designed to carry up to 200 pounds at up to 10 miles per hour. It's a neat system and would be a great tool for soldiers in combat, but the HULK's insatiable appetite for power is a persistent problem. And though recent advances include extended battery life, there's no getting around the fact that the system needs a constant source of juice. Enter the Sensora motor enhancing suit from researchers at Hiroshima University in Japan. The Sense relies on the body's own muscular and nervous system to reduce the muscle load of the upper limbs and maximize the force it's able to provide without strenuous activity, or more importantly, a power source. The system is first and foremost lightweight and inexpensive. It's made of intelligently layered, flexible fabric and doesn't contain motors or any sort of rigid framework or electronics. Of course, this means wearers won't be bench pressing missiles or other heavy-duty equipment, but the system's lightweight makes it appropriate for seniors and other folks with reduced muscle function. So while the Sensora motor enhancing suit could be appropriate for military applications, and its inexpensive design could allow for wider deployment than a HULK, it could find great functionality in medicine and industrial civilian applications.
GE has developed a cheap, easy way to detect explosives. In an effort to improve counterterrorism efforts in the US, GE Global Research, in partnership with Technical Support Working Group, Quantum Magnetics, and ChemSense, have designed a flexible wireless explosive detector that can be used nearly anywhere. The penny-sized RFID sticker costs between 5 and 50 cents to make and have the ability to detect and measure very low concentrations of explosives, oxidizers, and chemicals. The sensors can be read in real time using an in-range handheld detector. When the sensor detects an explosive or oxidizer, it changes its electrical properties, allowing for detection. Because the location for the stickers can be basically anywhere, including cargo containers, walls, packages, and other places, and they can continuously operate despite heavy interferences, they seem ideal for shipping ports, railroads, or airplanes. Though GE is currently focused on the security aspect, the researchers also think the technology could be used to detect minute gas leaks, degradation of electrical isolation, and even bacteria and mold spore growth. The company also says because the technology is capable of detecting real-time measurements of chemical and biological properties, it has applications in healthcare, agriculture, and consumer sectors.
That's all for this week's video. Be sure to check in on Twitter and LinkedIn and see past episodes at ecnmag.com. For the ECN channel, I'm Jason Lomberg, and this has been your Engineering Update. Wait, no Facebook?